Hello and welcome, and in this video we're going to talk about adding and subtracting matrices, okay? So this should be a fairly quick video because there's actually not that much to adding and subtracting matrices, okay? So I have three matrices. I have matrix A, B, and C on the top of the screen here, okay? And when we're adding and subtracting matrices, there's really not that much to it, okay? The one thing I'm going to point out right away is that in order to add and subtract matrices, they actually have to have the exact same dimensions, okay? So for example, remember that matrix A, I would say, is a 3x2 matrix because it has 3 rows and 2 columns, okay? Now, when we add and subtract matrices is actually probably what you would kind of expect, okay? So for example, if I try to do A plus B, matrix A plus matrix B, all I would do is, in this problem, since I'm adding, I would add their corresponding entries, okay? And what do I mean by that? Well, notice that in matrix A, 2 is in the first row in the first column. So I would just do 2 plus, and then the corresponding entry in matrix B, which is -4, okay? So I'll just do 2 plus -4 because both of those entries are in the first row and the first column of their respective matrix, okay? And then I would do 6 plus 10 because each of those entries are in row 1, column 2, and so on and so on. So then I do -1 plus 5, 10 plus -3, 8 plus 3, and 3 plus 2. Okay, and it would just be that simple. So now that would get me that A plus B is equal to -2, 16, 4, 7, 11, 5. And it's that simple, okay? It's actually just that simple. That's all that matrix addition is, okay? Subtraction would work the exact same way. So if I tried to do, let's do actually B minus A, okay? And order does matter, okay? Just like if I was doing 5 minus 3, that would be different than 3 minus 5, okay? The commutative property does not hold up with subtraction. It does with addition. A plus B is the same as B plus A, just like 2 plus 3 is the same as 3 plus 2, but subtraction does not go that way, so make sure that you're being very careful here. So with B minus A, I would just go ahead and subtract the corresponding entry. So now I would do -4 minus 2, and I would do 10 minus 6, and so on and so on. So I'm going to go ahead and speed this up. And this would end up being our resultant matrix with -6, 4, 6, -13, -5, and -1. Sorry for how sloppy my handwriting is. I'm getting a little sloppy lately. So that would be B minus A, okay? So let's go ahead and get this out of the way. Okay, so remember earlier I said that in order to add or subtract matrices together, they have to have the exact same dimensions, and now that should you should now kind of see why. So for example, if I try to do matrix A plus matrix C, notice that matrix C is a 2x2 matrix, something that we actually call a square matrix, okay? Not crazy important, but it is kind of useful, okay? So notice that these two don't have the same dimensions. So if I were to try to add these two together, well, 2 and 1 and 6 and 3, so far it seems to work out. But notice when I get to the third row of matrix A, there is not a third row for matrix C. So this is actually not defined. I cannot add these together. That is why. Because adding and subtracting matrices is just by adding and subtracting their corresponding entries. And if there isn't a corresponding entry to match up with, I simply cannot do it, okay? So that is why we need to have the same dimensions, okay? And there's just one more little thing that I want to talk about, all right, is something called the additive inverse, okay? Actually, let me write that down real quick. Okay, the additive inverse is simply the matrix that you would have to add to a matrix for all the elements to cancel out and result with 0, which is actually what we call the zero matrix. A matrix with all the entries of 0 is what we call the zero matrix, okay? So it's actually pretty much the exact same as our normal additive inverse. If you think about the number 10, its additive inverse is -10, because if I try to add 10 and -10 together, they end up canceling out, resulting in 0. So with matrices, that actually works the exact same way. So for example, the additive matrix for, the additive inverse for matrix A would be -2, -6, +1, -10, -8, and -3. And notice all that happened there is that we switched all the signs of every entry of matrix A, because now if I were to add these two matrices together, all their elements would end up canceling out and result in 0. So this would, if I add those two together, all I would get is 0, 0, 0, 0, 0, 0. Okay, so that is what the additive inverse of a matrix is, and that's really all that you need to know for adding and subtracting matrices. Okay, so in the next video, we're going to cover multiplication, which actually is a little bit more complicated. So make sure you stay in tune for that next video. And as always, if there's any questions, please let me know below. Thank you. I look forward to seeing you guys in the next video.